welcome to Unit 3. So in this first video for Unit 3, we're going to talk about understanding and representing exponents. Evidence-wise, we're going to define what an exponent even is, look at two ways to represent exponents. There are two different things that we can use for them, and then we're going to talk about how you can actually calculate things that include exponents. Learning experience is a little bit long. We're going to talk about a definition, we're going to look at some representations, you're going to do a you-do, there'll be some things to remember as per usual, and of course we'll end with some suggested practice problems at the end there. So what even is an exponent? Well, an exponent is just something that represents repeated multiplication. So for example, we could have 2 times 2 times 2 times 2, which we could represent as 2 to the 4th power. That 4 is going to be our exponent. This is actually very similar to what multiplication is. I'm sure at some point you've learned that multiplication is just repeated addition. So for example, if we had 2 plus 2 plus 2 plus 2, that would be the same thing as 2 times 4. This is just the next level up. We have 2 times 2 times 2, 2 with an exponent of 4. So, what is this thing that we have here? Let's break this down into some pieces. Let's start with what this entire thing is called. This 2 with a 4, we call this entire thing a power. That includes two different things. It includes two different numbers. We have the 2, of course, and we have the 4. When we have both of those things combined, that is going to give us a power. If we look at just the 2, this thing is going to be called our base. What it's really telling us is what number we are using in our repeated multiplication. So here we see 2's, that's all that we have, so we know that that is going to be our base. That is what we use when we're making this power. The other number is our 4. This is actually the exponent. And what our exponent is telling us is how many times we are multiplying 2 by itself. So if we look, we have 1, 2, 3, 2 2's, 3 2's, 4 2's. So that is where our exponent comes from. That is where the 4 actually comes from. Now let's talk about how you can actually represent these. So there are two ways that we can represent something with an exponent. The first way is as a power. Here we have 3 to the 5th. That just means that we have a power. Our base is 3. Our exponent is a 5. That's one way to represent it. That is totally fine. Another way to represent this would be in expanded form. And what expanded form is it's going to look more like what we had on the previous slide. We're going to look at what our base is. So our base is 3. We're going to look at our exponent, and we're going to say, okay, so we're multiplying 3 by itself 5 times. That means we need 1, 2, 3, 4, 5 3's, which are all being multiplied together. This is another way that we can represent something with an exponent, represent a power. We can easily switch between the two of these depending on which one we need to use. But if you need to evaluate something with an exponent, if you need to evaluate something that's written as a power, the expanded form is going to help you do that. So for example, if we were told to evaluate 3 to the 5th power, we would actually have to do this multiplication. Best way I would suggest is do it one number at a time. So for example, we can do 3 times 3, which is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is, of course, 243. So we could also represent it this way. If we wanted to, we could say that this power, 3 to the 5th, is equal to 243. We could also just write it in expanded form, whichever way works best. Next up is a you-do problem. This time we have 5 to the power of 3. You're going to write this in expanded form, in expanded notation, and then you're going to evaluate it. So just like what we did in the previous slide, except this time your base is 5 and your exponent is 3. Ready, go. Things to remember for this video. Remember that an exponent represents repeated multiplication. The base, which is the big number on the bottom, tells you what number that you're actually multiplying. The exponent is the small number on top, which is going to tell you how many times to multiply it. And together, the base and the exponent, they make a power. Anything with an exponent of 0 will have a value of 1. We didn't talk about that in this video, but if you'd like a separate video explaining why that's the case, please let me know. I'll be happy to make that. Just know that if you see something written like so, let's say 2 to the 0th power, that will equal 1. It doesn't matter what your base is. If the exponent is 0, it's going to be 1. So I've got a number of suggested practice problems for you. In the first 4, you're going to write each power in expanded form and then evaluate them. The next set of problems, you're going to just write each expression as a power. So think about what is your base, what is your exponent. And then there's one at the end. This is a challenge problem, but you're going to evaluate that power. You might have to think about something in the things to remember to help you with that one. Good luck!